Welcome to today's webinar. My name is Katrina Power and I'm the manager of the Circular Bioeconomy Cluster Southwest. And we're based at Munster Technological University. And I'm so delighted today to be able to host and co-host the Circular Bioeconomy Innovation Exchange with our colleagues from the Interreg funded project called FanBest, and also our colleagues from the CircBio Research Group and Munster Technological University as well. We have a really exciting lineup of speakers who are going to be joining us today. And we're all going to be talking about the topic of ecosystem services and blue carbon in the marine sector. And this is a topic that is, I guess, very much top of mind for a number of people, including ourselves, as we're navigating, well, how do we address, ocean sustainability challenges? What's the ecosystem services potential? What's the blue carbon potential? Are there ways to measure it? Are there, what's the accreditation? Who's investing in this space? Who are the interesting companies and who are the researchers? So the purpose of today's session is to demystify this a little bit. And we have an excellent lineup of speakers to help us. So we have Dr. Alexandre Tahar. He's from the MOREFISH project at NUI Galway. We also have Professor Brijesh Tiwari from Teagasc, who's going to be speaking about the seaweed biorefining and the potential for that. We have Stefan Kraan from the Seaweed company, who's going to talk about blue farming and seaweed. Also joining us today from France is Pierre Erwes, who's from the BioMarine capital, who's working on a lot of seaweed projects and investing in those as well. And then also our colleague Laura Foley from the Circ Bioeconomy Research Group and the FanBest project. And there's myself as well, and I'll be doing the moderation today. So here's our agenda. So we're going to start in that order. And I would like to invite Dr. Alexandre Tahar to jump in and to start introducing himself and to share his screen, please. You're on mute, Alex.
Sorry, that must be better, I suppose. Thank you, Katrina, for the introduction. I'm gonna just share my screen now. Hopefully you can see what I see on the screen. So yeah, again, thanks for the introduction. I'm really glad.
Sorry, Alex, we don't see it. Do you want to try again?
Yes. Sorry about that. That should work now.
Great.
Okay. So again, thank you for the introduction. I'm really glad to be here and to talk a little bit about research around ecosystem service provided by the Irish shellfish aquaculture sector. So just to give you a little bit of context on my research group, which is based in NUI Galway. So we started in 2015 with a project called MOREFISH, which was dealing with benchmarking the environmental performance of the freshwater aquaculture sector. And from there, we developed a suite of different projects. EcoAqua was more on the more based on intensive monitoring on, again, freshwater fish farm. And from that point in 2017, we got involved into an EU project called Neptunus, which deals with LCA and eco-label of seafood products across the Atlantic area in Europe. Then we worked on a project called AquaCatch, which was dealing with comparing different food production systems and including aquaculture and terrestrial agriculture at a catchment scale regarding their impacts and their emissions to surface water. And now today I'm here to talk about a new funded project by BIM called ShellAqua. So I'm gonna just drive you through the ShellAqua project. How did we get the idea? And so it was based on an industry identified kind of gap of knowledge in the fact that they knew and they still know they are producing some good quality food. They also know that they provide an ecosystem service to the aquatic environment, but they they had loads of questions about that, and they wanted research to be done on these topics. So from there, we developed some objectives of this project. The first one would be to quantify how much carbon, nitrogen, and phosphorus is removed from the aquatic environment due to shellfish production, and how could we value this service in terms of monetary value. The second objective was more based on life cycle assessment of shellfish product in the aim of identifying where are the environmental impacts of producing shellfish, and also how could we compare that to other food products. So just to clarify what I mean by ecosystem service within the Shell Aqua concept, because it could be, cultural ecosystem service, it could be bringing more tourists to the area, something like that, but this is not what I'm going to talk about today. Today, as it's illustrated here on this schematic, I'm going to talk about the removal, nutrient and carbon removal ecosystem service, which is based on the hypothesis that since shellfish are not fed in the marine environment when they are cultivated, all the nutrients and carbon they need to build their tissue and shell, they take it from the water. So when they are harvested, it can be considered as a removal of nutrients and carbon from the seawater. So the question is how much. There is now a good bit of literature on that, but nothing is specific to Ireland. Most of the studies would be in the US, and so it could be on different species, different water quality, and also Irish specific data are needed. So just a little point on the species that we are studying on this project, which are the main shellfish species in Ireland, which is the Gyga's oysters, the native oysters, and the blue mussel. And we have different partner sites on the west coast of Ireland, which will allow us to study the impact of water quality and all that on the amount of carbon, nitrogen, and phosphorus removed. So then to get into, it's going to be a little bit technical on the next slide, but yeah, how do you get the amount of carbon, nitrogen, and phosphorus removed by shellfish? So originally we thought of kind of mimicking kind of a marine environment in our lab and doing some sort of mass balance with recording and monitoring of water quality. But we realized how much it would have been so difficult to reproduce this sort of environment. So we took a slightly different approach, and we decided to focus on harvest size shellfish that we will sample on the different sites. And then we will perform morphological analysis on these shellfish, and we will then analyze them in tissue and shell for the percentage of carbon, nitrogen, and phosphorus contained in them. And so that will give us a good basis for correlation to the morphological parameters and all the water quality data that we are going to record in all the bays that we are studying, such as temperature, salinity, current, the amount of chlorophyll, the nutrient flows going into the bay, and also correlate that to the cultivation systems, because shellfish are cultivated in many different systems. And this, from the literature, seems to be a parameter that is quite impacting on the amount of carbon, nitrogen, and phosphorus removed. And then from these, we'll be able to extrapolate the data on a per ton basis, on a per hectare basis, and also to farm, bay, catchment, and maybe national scale. So this project just started, so we don't really have results to present to you now. We are going to do that part of the project in the new year, so we'll have results soon, but there's no proper results there. So as I said earlier, the second objective of the project is to run a life cycle assessment of shellfish production in Ireland, which hasn't been done yet. So maybe just a slide on what is life cycle assessment. It's a standardized methodology which allows to assess and quantify the environmental impacts of a process or product across its whole life cycle. So that includes, of course, the production side, but also the processing, transportation, and all that. So what you get from that, in a nutshell, is a little bit more than the old carbon footprint. You also get water footprint, energy footprint, data on land use, and all. It's basically environmental accounting of a product throughout its life cycle. So doing that, you can identify where are the environmental hotspots, meaning where, if I want to reduce my environmental impacts, where should I act and what should I do? It allows for scenario analysis. For example, if you want in the future to put a wind turbine to generate the energy on your site, how would that impact your global environmental impacts? And it also allows to compare different food products on a standardized methodology, so standardized and reliable way. So just to give you some examples from what we've done in previous work. So in aquaculture, the objective was to compare aquaculture and terrestrial agriculture in terms of food production at a catchment scale. So just a graph here to show you globally on a series of indicators, how did aquaculture perform? Aquaculture is in blue here, against cattle, sheep, and in general, agriculture in this catchment. So I'm not going to get into detail on this graph. I think it's, I could talk for hours on that, and I don't have that. So what we could see is that aquaculture was performing better on a per ton basis on most of the parameters we analyzed, such as eutrophication potential, land use, global warming potential, and energy. And that agriculture, on the other side, was performing a little bit better on some aspects like water use or phosphorus emissions to water, which was mostly related to feed use in the aquaculture site within this catchment. So coming back to shellfish, again, we don't have, we only have preliminary results that still needs to be validated. So I can't give you the values for energy, carbon footprint, but there will be there soon. So here's a kind of a comparison of different seafood products across Europe with the Irish mussels. And today, what I can show you is, because we are talking about food, the nutritional aspect is also important. So we also include that into our analysis. And as you can see here on the nutrient-rich food index, which is based on the recommended values of nutrient intake that you need to take to be healthy, mussels seems to perform quite well. It's on the top range compared to other seafood products, and that's quite encouraging. And so these are all very encouraging results, but yeah, there'll be much more soon with all the species and all that we'll have in the new year. So just to wrap up on this very short presentation on the expected results of this project. So we hope to address the gap that is existing in knowledge for the industry. We hope to develop tools that will allow shellfish farmers to have a good idea or to estimate their carbon, nitrogen, and phosphorus removed. And we hope to provide them with a tool for them to estimate that from simple parameters such as the average production, the average size of their shellfish, which these parameters are already recording. We hope to give insights on the valuation of this service. There are options in the literature on that. For example, if these nutrients were not removed by shellfish, they would have to be removed on land, and how much would that cost? And this is one approach. We hope to develop some sustainability tool based on life cycle assessment to help them with the valorization of their waste and to propose some eco-labeling. And that's pretty much it for me. Thank you for inviting us to talk here today. I'd like also to thank BIM for funding and to thank my team, because again, I'm not alone here. So I'm representing a team made of Alan Kennedy, Ron Cooney, and Owen Clifford in NUIG. Thank you all.
Thank you very much, Alexander. A really insightful presentation. But also what's interesting is that I think for the shellfish farmers as well, it's looking to add value by having an eco label, for their product, as well as trying to find, value for their waste streams as well, and maybe possibly make it into a bioproduct as well down the line. So I think it unlocks a lot of opportunities, which is what we're all working towards, I guess, in the blue bioeconomy. Thank you so much. I'd like to welcome Dr. Brijesh Tiwari next to the screen, and to please share your screen as well. Thank you.
Good afternoon. My name is Brijesh, and I'm going to talk through marine biorefinery for sustainable exploitation. And the brief presentation outline is to start with economic relevance, and then a few examples related to biotransformation, value addition, and drawing some key conclusions. So most of the...
Sorry, Brijesh, we can't see your presentation. Can you share it there?
Sorry, I don't know. Oh yeah, sorry.
So while you're doing that, I just want to encourage people as well, if you have any questions you'd like to ask the group here, please put them into the Q&A box and we'll address those at around 1:45. Thank you.
Yeah, apologies for that. So I'm going to go talk about marine biorefinery for sustainable exploitation, and presentation outline includes economic relevance of seaweeds, and is gaining a lot of recognition both from consumer as well as industry, as well as from environmentalists, and going through some of those biotransformation and value addition approaches what we have been adopting here, and drawing some few conclusions out of it. So the key research programs which are ongoing at the moment are related to BioOrbic, that's Bioeconomy, SFI funded Bioeconomy Research Center, BioCarb, that's EU project, Aquatech, which is funded by Marine Institute as a part of Blue Bio, and Interreg, that's enhanced microalgae. And some of the information what I have it here on sustainable aquaculture is from Teagasc. That was a report is available online on EC portal, which talks about different what's the best way or sustainable way of growing seaweeds. Now, first and foremost question what everybody is asking at the moment, whether it's from consumers or from industry, is really seaweed a sustainable solutions? And one of our panelists here, Pierre, will go through a lot about seaweeds and all, so I'm not going to go deep into any of these aspects. However, what we see is has to be a balance between whether wild harvest versus aquaculture. And we all know the importance of seaweeds as far as environment and ecosystem is concerned. So at the moment, the seaweeds, they do play a real economic role for our future challenges and the current challenges, and they can and they have ability to address some of those sustainable developmental goals. But what you can see is direct involvement with a number of different sustainability developmental goals, and they can play a major role on addressing protein deficit, food shortage, population, as well as climate change. However, when it comes to aquaculture seaweed or seaweed production itself, you will see there is a huge increase in the production in last 50 to 60 years, whereas Europe lags behind both for aquaculture and harvesting of seaweeds. And to add economic relevance to this, first and foremost is biomass exploitation. That is, it is a source of a lot of key ingredients, carrageenan, agar-agar, alginates. We do use these ingredients not only for food applications, but historically it is being used and still in use for a lot of chemical labs as well as microbiological media. Food and supplements, rich in protein, they're a good source of waste minerals and dietary fibers. They have a potential for feed ingredient, fertilizers, and low-grade plastics. That means to replace current petroleum-based plastics, pharmaceutical, cosmeceuticals, nutraceuticals, biofuel, and n number of applications. The biomass can be exploited. But there are significant challenges. For instance, current carrageenan production or agar-agar production or alginate production includes a lot of different types of chemicals in the processes. Hence, the processes, the byproduct or side stream, what we obtain from these systems cannot be used for other purposes. And the environmental benefits as well as ecosystem services, whether it's erosion, carbon sequestering, and capture of carbon dioxide, CO2 into different sequestering. Either we call it either carbon offset or carbon sequestering. So there is still debate is ongoing at the moment. Now, the most important element when it comes to seaweed processing is balancing 3 E's, that's economy, environment, and ecosystems. So how do we go for it? There, basically, at the moment, if you look into seaweed businesses, whether it's aquaculture seaweed or wild harvest, first and foremost is to develop an alternative on-farm processes. Majority of the seaweed which is produced in Ireland or in majority of the country, seaweed is harvested, cleaned, dried, and drying process is not really energy efficient. So there are strategies, and we've been working on the strategies how we can preserve fresh seaweed or how best we can use instead rather than going for energy intensive processes. Second is to employ disruptive technologies along the processing of seaweeds, whether it's drying steps or processing into different value chains, or to have a better quality of the product. So once we employ better on-farm processes and employ disruptive technologies along the seaweed processing, we will be able to achieve zero waste approach. That means having no waste in the processes. And this zero waste approach is one of the critical aspects of Green Deal from the EU bioeconomy perspective. So that's by following these 3 key steps related to this, we'll be able to really unlock the potential of seas and ocean, which will make some of the positive benefit of the seaweed. So what are the 2 approaches what I mentioned about? One is biotransformation, other one is value addition. By biotransformation, I mean is to take seaweed as a biomass and to reinvent a process line, or to reinvent a process line in such a way that we green the process and we use every component of it. Another approach is to add value to the existing processes. That means looking into the process currently exploited for alginates. Majority of seaweed is exploited for polysaccharides for different applications, for agri-food application and non-food applications, and how we can convert that into to green the process. So one of our bioorganic approach here is, it's for instance Irish seaweed, whether it's aquaculture or wild harvest, to come up a new technique for primary processing that includes drying and converting or preserving the fresh seaweed. And here the role is not on the harvesting side. We are not currently involved in harvesting of aquaculture seaweed from sea farms. Second approach is, once we have a primary processing carried out, how do we establish a secondary processing, and so that we can get various products out of it. So that secondary processing will largely depends upon the application. Suppose one of the processor is interested in using seaweed for animal feed, but there is a possibility of also to obtain plant stimulant simultaneously. Or if process is for alginates, so there are certain side streams which can be used for as a functional ingredient. So by adopting this principle, that means to look at the holistically from source to the end product, we'll be able to develop circular resource efficient systems, can develop different nutritious product which can contribute to a sustainable and healthy diets. And we will be able to develop, empower local rural communities which are based on in the coastal regions. Now, again, the approaches here, as I mentioned about from primary processing side, is post-harvest treatments. If we replicate what we do with the fresh produce, and if we replicate how the fresh produce is preserved either by cleaning, soaking, blanching, drying, high pressure treatment, osmotic dehydration, ensiling, there are a lot of different treatments are there. We've been investigating a range of different techniques, And we come up with a lot of different processes where we can preserve the fresh seaweed as an energy efficient conversion systems. And second approach is to come up with a green extraction. By the green extraction, I mean to replace the chemicals which are currently in use, or to use processes which involves less of energy. For instance, if you look into a standard process of alginate extraction from a seaweed, so our approach here is to how do we green the process. For instance, it's a bit technical flow diagram, but it's relatively very simple. When we use biomass, it has to either to be given acid treatment. How we can replace these particular acids with a greener alternative, we have been successful in doing so. And once we get different fractions, there are impurities here. These impurities mainly contains laminarin amino acid, which have shown potential for flavor enhancers or fluorotannins. So these, if we green the process, these which is currently used as waste can be utilized. Again, algal residue over here, this is rich in protein and fiber, so techniques are required to valorize these proteins and obtain algal fibers. Other important element over here is most of the processes includes ethanol, and in some commercial application, ethanol is not used due to different approaches. Here, membrane technology and to replace the solvent with alternative greener chemicals. So by doing so, we are able to develop a process which is much more sustainable, and we can achieve circularity in the process. That means to get multiple value chain out of a given seaweed biomass, and how we can add value to the seaweed by adopting greener processes. So I know I'm running a bit out of time. So this is one of the biorefinery concept for seaweed. That means to have energy efficient conversion system, whether we use dry or a wet, and to develop a feed or a food chain. And this is one of the technology which is mentioned here, that's hydrodynamic cavitation, but there are a number of different approaches which are capable of converting wet biomass into different value chains, whether it's food additives, bioactives, and biochemical. So in a nutshell, we can utilize every fraction of the seaweed. So one of the key challenge associated with the seaweed is the legislative issues. And I've quoted here 3 key important macroalgae which are grown and used in Europe. There are different types of regulations. There are different directives which are related to aquaculture production of seaweed. And another key hurdle over with us here is to have regulation related to novel food. Although seaweed itself can be used directly for food consumption, however, when we obtain different ingredients out of it, it has to go through novel food regulation. So these are some of the challenges which are causing a problem for sustainable exploitation of seaweeds. Apart from that, there are certain seaweed which has shown positive impact on having on methane emission from animals. But however, that is with Ascaropsis, which has been a lot of investigation is going on that front. However, that's an invasive species for Europe, so it has to come under different protocol, different legislative issues. So in order to draw conclusions, it is possible to achieve a carbon negative or neutral system. However, we have to have transformational and translational approaches, and we cannot take a process, for instance, only drying as in isolation. It has to be a collective effort from the growth, that is from aquaculture production, processing, as well as end users. So in order to adopt a circular economy, we have to follow the biorefinery process, and multiple stakeholders has to come together. And with this, I conclude my talk, and wish to acknowledge generous funding from various agencies and current and past researchers who have been involved in achieving what is being presented here.
Brilliant. Thank you so much, Brijesh. If you'd like to just stop sharing your screen there, please, that would be great. Really insightful. I think, the zero waste approach is a no-brainer, but I also, what I take from your presentation as well is like if we're going to harvest seaweed, if we're harvesting seaweed, taking the most economical approach to extracting the value from that in this kind of zero waste process it's a no-brainer really, and it's very much unlocks economic and enterprise opportunities as well. So I'd like to now invite Dr. Stefan Kraan, who's going to talk about the Seaweed company. So we're going to get a company perspective now. And so, Stefan, if you'd like to share your screen, please.
Yes, thank you, Katrina. Let's first do this before I start talking and there is nothing on the screen. Can you see this okay? Hello?
Yeah, we can.
Yeah,
Thank
okay,
you.
Perfect. Well, first of all, my thanks to Katrina for inviting me to talk at this circular bioeconomy cluster and give a company perspective in the role of carbon in the marine environment. And in this case, it will be about the blue farming concept and the role of seaweed. Before I start with that, I just introduced the company very briefly as well. I'm myself the Chief Scientific Officer of the Seaweed company. And the company itself is a revenue generating seaweed frontrunner at the moment. We have developed a global seaweed platform with a biotech impact play. We do our own cultivation, we develop our own products and marketing concepts. We have already a proven market traction in Europe for the blue farming, blue health concepts. And of course, we are a climate and environment positive kind of company because we work with seaweeds, grow seaweeds, strong science-backed team with a variety of expertise, and then of course that yields all a compelling and value-creating impact story and credentials. And just to give you 3 examples there, we work, for example, with a big brewery in the Netherlands. You know them probably from the brand Bavaria beer, and they do all their winter barley with, for example, the biostimulant that we produce from seaweeds. Another one is this can that you see here, which is a hard seltzer. It's a triple distilled gin with seaweed flavor. And again, we provide the extract. We are on the can with the company logo, and we get 10 cents of every can sold. And that 10 cents goes back into seaweed cultivation or seaweed farms. So what better way than to drink away your carbon footprint in a way. And then finally, an example is the Carbon Market Challenge that we were one of the top innovators, and with 10 other companies, we're the only one in marine space, and that was announced at the World Economic Global Forum. So what are the problems that we look at? Well, there are big societal problems, of course. One is, of course, sustainable farming, and that can be crop as well as animal husbandry. We look at ocean restoration, specifically acidification, sustainable diets, no-brainer, using seaweed there, already hinted by previous speakers on protein deficit that is coming with a growing population. Climate mitigation, again, CO2 sequestration, coastal ecosystems, as well as human health and well-being, and that all funnels back into those sustainable development goals from the UN. What are we doing? Well, we grow seaweeds, basically, and we do that in different places around the world. We have our headquarters in the Netherlands, where we do small-scale projects. Of course, Netherlands is not the best place for seaweeds. Ireland is much better, of course, in that respect. And we have farms in the north of Ireland, in Mulroy Bay, as well as in Clew Bay, where we grow certain species of brown seaweed. In Morocco, we have our green seaweed operation, and in India, we have even 2 operations where we do red seaweeds. And we also develop our own technology for automatic seeding, automatic harvesting for these species. And we are also involved in offshore projects through EU projects, and we're trying to grow seaweeds in the North Sea, but that's a whole different ballpark altogether. Then back to the blue farming concept. What we're trying to do is to support the transition basically to a sustainable and organic farming environment. And while doing that, to regenerate oceans and coastal communities and contributing to climate. So if you look at the land side of agriculture, it is providing better health and well-being for the animals, soils and plants in a way to produce a higher quality, a better performance, higher yield, having less use of harmful inputs, of course, contributing to climate through CO2 mitigation and economic benefits for the farmers in the end, because in the end, money talks. So While doing that, we also then contribute to the ocean regeneration, looking at climate contributions, the de-acidification, restoring biodiversity, and also providing employment to locally operated seaweed farmers, where we guarantee them jobs, income, and security. Now, our goal is in a few years to have about 500,000 blue farmers on the books, about 25 million animals that are on a seaweed improved diet, about 1 million hectares of land regenerated, and that should yield us then about 25 megatons of CO2 mitigated, 4,000 seaweed farming jobs, and 3,500 hectares of seaweed farms globally. And we are already a good end on the way of this within India, Morocco, and here in Ireland. So the seaweed company uses basically the blue power of the sea to accelerate the transition to regenerative agriculture. And we facilitate this concept through the range of our top health products, one for plants, but a lot of different animal feed additions as well. But leaving the animals aside, I just want to focus for a moment on soil organic carbon. And soil organic carbon, basically the carbon in our soil, which can be bound either to particulate organic matter or mineral associated organic matter. The particular organic matter is a very short lifespan, is in the soil for a short time, and then is taken up or removed again. The mineral associated is staying much longer. And there is a story to tell about soil organic carbon. Because if you look at a global scale, they have estimated since 1850 that there has been 66 billion tons basically gone. And if you translate that into tons of carbon, since 2010, we've lost about 133 gigatons of carbon, which is the equivalent of 488 gigatons of CO2. And at that little of the picture that you see here, everything in red is where we have lost most of the carbon, and no surprise, Europe, China, and the US, and some places where we actually have gained a little bit of carbon in the soil. Now, if you look at soil organic carbon in respect of climate change, in the total world, basically, we have still a reserve of 2,400 gigatons of carbon, up to 2 meters in soil. If you see what we release every year in CO2 or from fossil fuels and emissions, it's about 8.9. And you see that little red dot, and you see the big golden circle. And well, if you put them on each other, you're talking about 0.4%, basically what we emit of that storage in soil and what we emit out in the air. So if we can balance that and bring about, well, 9 gigatons of carbon back into the soil, that would be already a good start in solving the carbon crisis, basically. Now, what we have discovered by using our plant biostimulant from seaweed, by doing all these trials on different types of crops, is that we basically bring back 11 tons of carbon per hectare on top of the normal use of NPK fertilizers. And that is something interesting. And although it's not a huge number, if you start applying this to more and more land, you can come up to higher or bigger numbers. And the 11 tons of carbon are equivalent to 40 tons of CO2. So doing these trials, and they mainly took place in the Netherlands, there's a couple of things that were very eminent. And I'm not going through all the text, but just at the infographics, you can see, especially for moisture content, and this is of course caused by the polysaccharides in the seaweed, that we had a dramatic increase in soil moisture content, especially in the top layer. In the first 10 centimeters, even a 700% increase, and even up to 30 centimeters of that, still 6%. And of course, that helps with yield and drought resistance, with drought stress, and all this kind of stuff. If we then look at yield, and in this case it was onions, there are a couple of explanations why this is happening. Plant hormones, minerals, trace elements that are coming from the seaweed, but also the at genetic level processes that they stimulate. And we get on average about a 21% increase in yield in onions. Now, same thing we've done in potatoes. And these are substantial areas, and 1.5 hectares, 3 hectares. It's not a 1 square plot where we do something. And we see big increases in yield as well, 22%, 12%. And we've started now with the trials with winter barley as well, with the big brewer Bavaria. So there is definitely something to go for this. And this whole process has been certified by ONCRA as well. And it provides an investment for carbon removal projects, which are sustainable and technically feasible and are ready to be applied in a real world scenario. So we are still level 2, but we are working on this development to go through the scalability pathways and to create data sets to go to level 3 as well. Of course, I understand as well, this is done in the Netherlands. It depends on what soil type, what crop you're growing, where you are in the world, what kind of agricultural practices you have. But looking at all the different elements, it looks like very much a win-win for companies, farmers, and the planet itself. If you look at the company benefits, you can offset your CO2, you support blue farming, ocean regeneration, work on regenerative agriculture, supporting the local farmers and paying for the CO2 removal. The benefits for the farmer then is increased crop yield, less use of pesticides and cost of pesticides, improved soil quality and possible usage, reduced water usage through the higher water binding capacity and transitioning in an organic sustainable farming environment. And then the benefits for the planet are, well, very obvious. Sequestration of CO2, so mitigation of climate change, deacidification of oceans by growing more seaweed, bigger seaweed farmers in different parts of the world, increasing biodiversity by this way, less use of synthetic fertilizers and pesticides, and of course less CO2 in the atmosphere. And that's my message to you for today. Thank you very much.
Thank you very much, Stefan. And if anyone wants to get in touch with Stefan, his email was there. And if you'd like to follow up, let me know. If you didn't catch that, we can always send out the email addresses of the all the speakers later. I think it was really interesting what you mentioned around soil carbon, because one of our members here, Southern Scientific Services, we actually had a presentation last month learning from them about how they're measuring carbon in the soil and what the potential for that is in Ireland as well as in other jurisdictions, but like looking at the instrumentation to how to measure that carbon change as well. And I think that would be all very important as we start to figure out our carbon removal strategies going forward. I'd now like to welcome Pierre Erwes from BioMarine Capital. And he's going to tell us, you know, for the investor perspective to working with blue bioeconomy and the seaweed value chain. So Pierre, please take it away. Thank you.
Thank you, Katrina. I'm Pierre Erwes. I'm the chairman of the BioMarine organization, which is one of the oldest and the largest marine biotech network in the world. When we're talking about BioMarine network, we have almost 3,000 active members, ranging from very large group around the world to small entrepreneurs. And the purpose of BioMarine and the mission of BioMarine is really to work on several types of projects. Aliga, which is our recent spin-off, which is, you know, the largest organic seaweed producer, and I will come back to this in a second. We have launched also the Seaweed Bioplastic Consortium, and we're helping a few companies to develop at international level and to become, you know, the key leaders, you know, in the seaweed bioplastic sector. We work also on cellular mariculture, which is, you know, the future, and try, you know, to not to deplete, you know, the feedstock and the plant stock, you know, in the sea, and try to work on the cell and produce, you know, for the cosmetic and pharmaceutical industry, the right ingredients, you know, through this technology. And we also involved in very advanced project, sea to space technology, where seaweed and microalgae will play an important role, you know, for the colonization of Moon and Mars. At this stage, BioMarine has been focused over the last 5 years on seaweed. And so we developed, you know, this network, and Aliga is our recent spin-off. We invest in women, and we have over 5,000 women working, you know, in the different farms around the world. We invest in training because, you know, training is key. We invest in sustainability because everywhere where we go, we choose carefully the site. There's absolutely no pollutant, no pollution. And we work also on the carbon reduction, as you know. Just to mention that it's really important, you know, to consider the environmental benefits of seaweed. And to that extent, seaweed is a key component, you know, in the fight of climate change. I'm not talking about sequestering in the long run, you know, the seaweed, but at least if you use seaweed for nutrition, for current application, including biofertilizer, you release the carbon, and most of the time the balance, the benefit is neutral. So we really want to dig into seaweed and carbon sequestration, developing the seaweed polymers sector, which will be the Scope 2, Scope 3, and Scope 4 emission best candidates. I don't think that even, when Alexandre Cousteau will provide, the result of a study, we'll have, a global consensus on how we're going to drive down, the carbon. And most of the people are speculating, and I see lots of blue bonds, developing on the assumption that offsetting carbon will be the solution. It is not. The solution is carbon reduction, and carbon reduction starts with switching the synthesis ingredient with natural ingredient. And we have some big names in Switzerland that are working on this. And the purpose is really to authorize, the use of a natural seaweed ingredient in the industry to replace E4 or 6, E4 or Z, and that will create millions of jobs around the world. So behind this, how are we going to finance, this new sector? We know that seaweed on the side of the climate change, is very important because it's also good for nitrogen reduction. And Australia has emitted some of the big cities in Australia, they're emitting new taxes on nitrogen that we can use to leverage, the seaweed carbon reduction through cultivation. Carbon capture is all over, as you know. Methane is also getting, some traction. I think that it's better, to eat protein, coming from seaweed and trying, to feed, the cattle with the seaweed to reduce the methane. But it's a matter of philosophy, and that I want to go into this. For the biodiversity, the benefit of seaweed is huge, because when you cultivate, and multi-trophic is an option, when you combine shrimps, mussels, shellfish with seaweed, you can create, a very positive circle, and the value in terms of biodiversity is essential. It's also coastal protection, because we know that the natural seaweed can reduce by 30% the waves energy, and for the bioremediation, it's one of the key components. So we work on all these topics at BioMarine, and we have companies for which we're raising funds, taking them public, accelerating them in all the field that you see on the screen. Bioplastic is one of our favorite, but we work also on H2 development with big and oil and gas companies. We work on protein with some of the leaders in the world. And we have some very good, partners in the cosmetic industry and also in the pharmaceutical industry, because the seaweed are a key component in the anti-COVID treatment, but not only, it's also very efficient, in the norovirus, and it's very promising because it could be also used to replace some of the coating and very polluting, chemical components that we have, in personal care, in fiber, in textile, and the ink. So I would say that seaweed at all levels is crucial for the industry, but how are we going to finance this? So this is why, we started the Aliga. We have already 3,000 hectares around the world. We have farms in Alaska, British Columbia, on the East Coast, Quebec, Maine. We have a farm in France, Tunisia, Zanzibar, Mozambique. We have farm in Australia, and we're going to be at 2.3 million hectares by 2030. So we have developed, some financial vehicle, and we work with investment bankers. We work with blue bonds. We work with private equity and family offices, and we want to attract capital to accelerate the farms through Aliga. So the scope is very simple. We take, ESG money, or we take private money, we accelerate the farms, and the farm are supplying, some of the key partners that we have in the industry. And just, the leader in our Aliga network is just for this year, we have 200 million in offtakes with the large industry groups. And we expect, to double this production in no time. And we're working, on developing 3 new GMP plants, around the world to access the different markets. it's not how we're going to grow, it's how fast we're going to grow. And it's just, by this collaborating model that we're developing, access to capital, but access, to big, large industry, because BioMarine has been in the scope, of this economy, for almost 15 years. We know them all, and we give them access, to the raw material. So it's how fast we're going to go, how fast we're going to attract capital, to accelerate this company, and how performant we're going to be, because most of the seaweed is coming from Southeast Asia. They are not very valuable because they are full of heavy metal, pesticides, and hormone. And all the seaweed we are developing through Aliga, they are totally organic, no chemical transformation, and we have, the entire value chain from cultivation to end user product, and we master the cost, thanks to this global understanding. It's very good, to be able, to deliver good natural product, and we insist on that. All the farmers that we're recruiting in our network, they should be totally organic, and we have very strict policy on this, and we monitor that through blockchain and audits every year. But the rest, is coming from the synergies between the partners that we have, and some of the plan that we have, will serve the purpose of the farmers that have not, reached to that point. And investing is coming through the BioMarine Capital Network. And most probably the best way will be to de-risk that, and Aliga is the perfect vehicle, because we don't have one farm, but we have many farms. And the more we grow, the more we de-risk, the investment in one farm. So that's pretty much it. I'm happy to answer any question you have. And yes, and if you need to talk to me, I'd be happy.
Thank you very much, Pierre. Very interesting. I guess I have a question for you as well. Like, from an investor financial perspective, and from your group of investors that you're working with, like, what are they looking for, and what's driving them to invest in this space?
So we have three categories of investor. We have people doing impact, and that there's plenty of money, coming, from that side. But impact, most of the time is greenwashing. So you have to be careful, and we don't accept, this type of greenwashing money. So the impact is very useful, and when it's for a purpose, we take this money and we accept, to invest that in farms. The second type of investor is purely financial investor. They know that they're going to have a good return, because if you look at the raw material corn, for H2 production or ethanol production, went from $250, to $1,250 in less than 1 year. So if you can switch, to seaweed, then you're going to be sitting on the new gold. So some of the investors, they have understood that, and this is the second category. And the third category are more in between family offices that are looking for long-term, return on investment. They want to build something, and they are partnering with the industry. So they know that the industry needs this type of raw material, and they want to establish, this type of connections.
Great. And
I forgot to mention that since the beginning, we never use 1 cent of public funding.
Great. And so I have a question that's just come in here. And I think this relates actually to any company that's on the call. If there is a company, whether it's in Asia or wherever abouts in the world, and wants to join BioMarine, is that a possibility if they are cultivating with organic certification?
Yeah, organic certification is not enough for us. We need to test the water, and each time we establish a farm, there is a 6-month period where we're going to test the water, we're going to test the condition, the effluent, and if it passes all the tests, then yes, well, they will be welcome in our network.
There is a stage gate process. Okay, I have a question for Alex. And so Alex, if you want to just jump back on the call there. So when, you mentioned you've been doing this work in Ireland for, a few years now around LCAs and shellfish and the industry here, but like how does Ireland stack up comparatively with other countries?
Thank you for this question. So yeah, we're working on shellfish. It's very recent for us to work on shellfish. We've been working on freshwater aquaculture mostly before, especially since 2015. And I think as researchers in the research world, we are, as far as I know, pretty much the only one to do LCA of food product, of seafood product in Ireland. So there's not a lot happening besides us. It's just a small team. There's been, I was asking my colleague Ronan, who is the specialist, the LCA specialist in the team. And so yeah, there's been a few studies done. I see Irish fish canners done a few LCA studies on their processing. Another company did a small LCA study on chitin extraction from crab shells. Yeah, that's pretty much it. There's not a lot happening on seafood LCA in Ireland at the moment. And how are we compared to others? We are a bit late. For example, in Norway, they started that. They started to quantify carbon emissions from seafood products from 2003. So they are today at they produced a 10-year review on that. And they produced that, I think, in 2019, their second 10-year review of their carbon emission from seafood products in Norway. Some countries are much more dynamic than us, definitely. Spain, Portugal, France, Norway. We are a bit late, but hopefully with the product environmental footprint model that is in consultation at the moment, this will get traction, and people will have to produce environmental assessment of their products. So it will get there.
Great.
Yeah, I suppose.
Great. It will add a competitive advantage as well, I guess, to the industry as well. Now that, carbon footprints, need to be disclosed and things like that going forward. A question came in from the audience, and it's I think it's actually geared towards Stefan. And Stefan, I know you responded to in the Q&A, but I'm going to ask you as well out loud. Will IMTA with seaweed improve the LCA results of aquaculture in comparison to agriculture in relation to nitrogen input in the water? Quite a complex question. Very technical.
Technical. It is an aspect that they've been studying for a long time. IMTA systems where we have seaweed as an inorganic extractant, shellfish as the organic extractant like mussels or oysters, and then fish at the top there. And in the end, we were even at one stage where we were using the seaweed from an IMTA system that we would then add to the feed to feed it back to the fish. So basically, we made the fish eat their own shite in a way. So that was happening. And yes, it does happen, and it does work. And it is one of the systems we are establishing at the moment in Mulroy Bay with the Marine Institute, where we have all the big players involved, Mowi for one, the mussel growers in Mulroy, and then ourselves with the seaweed.
Very interesting. So what we're going to do now, I want to thank all our panelists, unless they have a final word they'd like to share with the group. I'm going to ask for Laura to jump in and to share some supports that are available from the FanBest project. It's a really interesting project. She'll tell you more about it. But first of all, before we jump to that, I want to say thank you so much to our panelists today for joining us. It's been an educational webinar, and I hope that you'll be able to get some contacts from this. I know there's some people who are really excited and want to probably reach out to you about various projects. And we'll definitely be sharing the recording afterwards as well with all the attendees as well. So Laura, would you like to jump in, share your screen and tell us about the FanBest project, please?
Thanks, Katrina, and thanks to all the other presenters. This has been a very informative event. Okay. Now, so my name is Laura Jane Foley. I suppose I'm the Enterprise Development Manager for the Circular Bioeconomy Research Group here in MTU. I've been working on an Interreg funded project called FanBest. So FanBest is a partnership between 9 partners across 5 countries. And the aim of FanBest is to support SMEs in the blue economy to access research and development, access support around technology transfer and funding and finance. So I suppose If you're a company in the blue economy, we're developing a coaching program at the moment. We're hopefully launching it in the new year. So if that's something that you'd be interested in, please do get in contact. So what is the blue economy? The blue economy encompasses all economic activities related directly to the oceans and seas. So that includes fisheries, aquaculture, coastal tourism, maritime transport, port activities, and shipbuilding. But as you've heard today, it includes new markets such as biotechnology, algae production, and oceanic renewable technology. Now, where is this funding after coming from? So recent research has shown there's a disconnect along the Atlantic area between blue economy SMEs and the necessary innovation support services that are required to help them develop their businesses. So that would be an example of that would be a lack of access to R&D specific to the blue economy, but more importantly, lack of access to financial instruments specifically designed for the blue economy. So as I said, it's 9 partners across 5 countries. So we're acting as a one-stop shop, I suppose, to support those areas of need for those companies. So we're doing that at the moment by developing this coaching program that I mentioned. It's a tailored coaching plan. It's one-to-one mentoring, half-day consultation with industry relevant experts. The coaching is free to participate, but there is limited spaces. FanVest, the coaching, as long as at top of the core coaching that's going to be provided, there's also access to an online business program. A socio-economic assessment can be carried out by one of our partners, Vertigo Labs. We also have one of our partners can provide a tailored mentoring around crowdfunding campaign. Where there'll be lots of support around financing and funding. And we have a number of networking events coming up. A lot of them have been online, but we're hoping that in the new year, there'll be in-person events. So the FanVest coaching program is open to all companies in the blue economy, including, I suppose, people at the idea stage. And if you're interested in getting involved, you can email me at laura.foley@mtu.ie and I can give you more details. Thanks very much.
Thank you very much, Laura. It's a great program for marine companies all over Ireland. So if you're a company thinking about, your growth and, where you want to go to next, definitely get in touch with Laura. And she's also building a really great network of companies operating in this space as well. So there's lots of opportunity for mutual learning there too. So what we're going to do is we're just going to close out the session now. And before I do that, I just wanted to share what we do at the cluster, and if anyone, if you'd like to get in touch and learn more about what we do. So at the cluster, we develop and promote collaborative projects, and we do that. We work with companies. We have about 25 members of different companies and service providers, and also state agencies involved. And we're working to solve challenges in agriculture, marine, waste to value, all focused on building new bio-based products, trying to establish how to figure out, to reduce carbon in the atmosphere, but also GHG emissions, and basically support environmental impact in a very positive way, but also through the lens of business opportunities. And when we're building these new value chains, you need collaboration. It's absolutely key. And so that's what we do here. And so if people are interested in learning more about the cluster, we do have a website, www.cbcsw.ie, or you can just get in touch with me. I'll share my contact details if you don't have them already. And what we do is, we support companies with services, whether it's around looking for funding, whether it's around networking, and we host these innovation exchange events as well, just like the one today, to be able to share that knowledge and to be on the cutting edge of all these trends and how to move forward and advance those into maybe interesting projects, or maybe just, unlocking some interesting connections for the folks in the network. So I want to say thank you very much to all our panelists for joining as well. Today, I think it was a really interesting and exciting webinar that we hosted, and it was something that was a little bit different for all of us. My main takeaways are that sustainability is very much on the agenda for this industry, and it's been driven a lot by emissions reduction, whether from the corporations and governments, whether it's scope 1, 2, and 3, but also there's lots of potential here to unlock benefits for farmers as well, but also at the primary producer level and for rural regions and coastal regions as well. So I just want to say thank you very much for joining. And if you're interested in learning more about what we do, just do get in contact.
Thanks, Katrina.
Thank you.
Thank you.